Hello everyone, I hope everyone you are fine and you are doing great. Welcome to today's tutorial. In today's tutorial we'll continue our discussion on mensuration of plane figures. If you have not watched the previous videos part 1 and part 2 of mensuration of plane figures, please watch those videos first and then only watch this video. Okay, so in today's tutorial we'll continue our discussion on mensuration of plane figure. Okay, so we'll take one question number 7 from exercise 18.1 on page number 322. Okay, now let us read through the question number 7 reads as, in the adjoining figure, this is the figure given to us in question number 7, the area enclosed between concentric circles. Now what is the meaning of concentric circles? If you have two or more circles with the same center, okay, so these type of circles are known as concentric circles. So they may be 2 circles, they may be 3 circles, 4 circles, okay, all these circles will be called concentric circles provided the center is exactly the same. So smaller circle, on that a bigger circle, then a bigger circle, but if the center is same, these type of circles are called concentric circles. So this is the perfect example of concentric circles. So there are 2 circles in here, one the smaller circle, and then with this center, okay, let us label this as O, and then we have another bigger circle with the same center O. So these are 2 concentric circles. Okay, between 2 concentric circles is 770 centimeters square. Now the area between 2 concentric circles is 770 centimeters square. That means this shaded region, okay, this I have shaded it by cross lines. Okay, the area of this shaded region is given as 770 centimeters square. If the radius of the outer circle is 21 centimeter, that means the radius of the bigger circle is 21 centimeter, calculate the radius of the inner circle. Okay, we need to calculate the radius of the inner circle. That means we need to calculate this radius. Okay, so if you closely look at the figure, this is in the form of a ring. 2 concentric circles, they form a ring. Okay, the ring which you wear in your fingers. Okay, so this is in the form of a ring. Okay, so capital R is equal to 21 centimeters. Why I have written capital R is equal to 21 centimeter? Because the radius of the bigger circle, the outer circle, is 21 centimeter, and small r is equal to question mark. Small r means the radius of the smaller circle is question mark. That means that is what we are looking for. Okay, now it is given in the question that the area of the shaded region, that means the area between 2 concentric circles, is given as the area, this area is given as 770 centimeters square. Okay, so with these information, what you need to find? We need to find the radius of the inner circle, the smaller circle. Okay, so area of the ring, so this appears in a ring form. Okay, so we take this figure as a ring. So area of a ring is equal to area of the outer circle, that means the area of the outer circle, that means the whole thing. From the whole circle, if you subtract the area of the inner circle, that means if you subtract this part, what you get? You get the area of the ring. Okay, I hope this is clear to you. So area of the ring is equal to the area of the bigger circle, the whole thing. From there, if you just take away, if you just take away the area of the smaller circle, then what we are left? We are left with this part. Okay, you can try it out. You take a piece of paper, okay, you cut it in the form of circle. Now in the same circle you cut a smaller circle. So what is the remaining you'll get? You'll get this figure. Okay, a ring. Okay, so area of the ring is equal to area of the outer circle minus the area of the inner circle will give you the area of the ring. Okay, now let us come to the working formula. So area of the outer circle, we know area of a circle is given by pi r square. So pi capital R square, since it is the outer circle, pi r square minus inner circle pi small r square is equal to 770. This 770 is given to us in the question. Okay, now pi and pi is common. Okay, common factor, so we take the pi common. So what is left over inside the bracket? R square, capital R square minus a small r square is equal to 770. Now the value of pi is 22 by 7. Capital R is 21, so it is given to us in the question 21. So capital R is 21 square minus small r square is equal to 770. So what do? We cross multiply. The 7 cross multiplies to the numerator and the 22 cross multiplies down to the denominator. So the 7 goes to the numerator and the 22 goes down to the denominator. So after cancelling, what do you get? 35 into 7, and 35 into 7 is your 245. That means 441 minus r square is equal to 245. From where are you getting this 441? 21 square. Okay, 21 square is your 441 minus r square is equal to, after you simplify this, you get 245. So 441, you transpose the 245 on the left hand side, so plus 245 becomes minus 245 is equal to minus r square. If you transpose it to the right hand side, minus r square becomes plus r square. So 441 minus 245 gives us 196 is equal to r square. So the value of r square is equal to 196, but we are not interested with the value of r square. We just need small r. Okay, we need to find the radius of the inner circle. Okay, so how do you get rid of the square? Taking the root on both sides. So if you take the root or rooting both sides, what do you get? Root under of r square is equal to root under of 196. So the square and the root cancels out each other, so you are left with r is equal to, and root of 196 is 14. Actually root under of 196 is plus minus 14. That means plus 14 also and minus 14 also. Okay, but we reject the minus 14, we ignore the minus 14, we just take the value as plus 14. Why do we take it as plus 14? Because r is length, and length cannot be a negative value. You can't have a circle of radius minus 14 centimeter. Okay, so that's the reason why we ignore the minus 14 and we take the final answer as 14 centimeter. So the radius of the inner circle is equal to 14 centimeter. Okay, so I hope the working of this sum is clear to you. So the most important thing here to remember is the figure. As soon as you look at the figure depicts a ring. Okay, so you just need to find the area. Well, the area is given, you have to find the radius of the inner circle. So area of the ring, so we need to formulate the formula, the working formula, and then it easily gives us the value of r. Okay, so I hope the working of this sum is clear to you. If you have any doubts, please raise your doubts when we are having our online classes. Okay, now let us take another sum with a different type of figure, and let's see how do we go about it. Okay, now let us see our next question, question number 9. It's from the same exercise, exercise 18.1. From the adjoining figure, that means this is the figure given to us, find the area of the triangle ABC. So a right angle triangle ABC is given. We need to find the area of the triangle ABC. Number 2, find the length of BC, and number 3, the length of the altitude from A to BC. Okay, now let us check the first question, Roman 1. Find the area of triangle ABC. So this is the figure given to us. Okay, so it is a right angle triangle. So from the figure it is quite clear, okay, that this is our base. Since the perpendicular is drawn on this side, so this becomes our base and this is our height. So what is the base of the triangle? EB is the base of the triangle, and what is the height of the triangle? AC is the height of the triangle. Okay, so the area of a triangle is equal to half into base into height. So area is equal to half into what is our base? Our base is AB, into what is our height? Our height is AC. So half into AB into AC. So area is equal to half into the length of AB is given as 3 centimeter in the figure, and the length of AC is given as 4 centimeter in the figure. So 2 1s are 2, 2 2s are 4, 3 2s are 6. So the area of the triangle ABC is equal to 6 centimeter square. So this will be the first answer. Okay, so area of triangle ABC is equal to 6 centimeter square. So this was a quite simple, straightforward question. So the base and the height is given to us, and we just need to find the area. So area is equal to half into base into height, which gives us 6 centimeter square. Okay, now let us check the next Roman 2. Length of BC. Okay, now this is a right angle triangle, and you are aware that in a right angle triangle the side which is exactly opposite to the 90 degree is known as your hypotenuse. So this side is your hypotenuse, this is your base, and AC will become your perpendicular. Okay, hypotenuse, base, and perpendicular. So the two sides are given, you need to find the third side, the hypotenuse. Okay, so by Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square. So this is the famous Pythagoras theorem. Okay, which is applicable for right angle triangles only. So hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is BC, which we don't know, we are looking for BC. So BC square is equal to perpendicular is AC and our base is AB. AC square plus AB square. So BC square is equal to AC is given as 4 centimeter, that means 4 square, plus AB is given as 3 centimeter, so 3 square. So BC square is equal to 4 square is 16 plus 3 square is 9. So 16 plus 9 gives us 25. So BC square is equal to 25. So we just need BC and not BC square. So how do you get rid of the square? We do rooting both sides. So rooting both sides will give you BC is equal to root under 25, which is equal to 5. So the length of BC is equal to 5 centimeter. So here we have used Pythagoras theorem to find the hypotenuse or to find the length of BC. Okay. Now let us move on to the third part, Roman 3, the length of the altitude from A to BC. Now this is interesting. Okay, the length of the altitude from A to BC. Now from A you draw a straight line, a perpendicular, it is given in the question. So you need to find the length of the altitude, that means this becomes the altitude, that means AD becomes the altitude, which is quite evident from the question itself. Since it's making an angle of 90 degree, this will become the altitude now. Okay, so if this is the altitude, which side will become our base? BC will become our base. Already we have discussed this in the previous classes also. To whichever side you draw the perpendicular, that side will become your base. Okay, that means if you flip the figure this way, if I am to show you in a rough work this way, so this figure will become this way. So this will become your A, this will become your D, and this will become your B, and this will become your C. So this will become your base and this becomes your height. Okay, so what we need to do, we need to find the altitude, that means we need to find the height. Okay, so just now we have calculated the length of BC as 5 centimeter, the length of BC as 5 centimeter. Okay, now again area is equal to half into base into height. Since we are not making any changes regarding the sides, okay, the length of AB is remaining 4, the length of the length of AB is remaining 3, the length of AC is remaining 4, and the length of BC is remaining 5. We are not making any changes to the side. So what will happen? The area will remain unchanged, only we are changing the position, only we are changing the orientation of the figure. So what will happen? The area of the triangle will remain the same, which we had already calculated in the first part of the question. So area of the triangle is equal to 6 centimeter square. So we'll use it here again. So area is equal to half into base into height. So area, which we had already calculated in Roman 1, 6 is equal to half into, now which side becomes the base? BC becomes the base into height is your AD. Okay, so 6 is equal to half into BC, we just calculated BC as 5 into AD, that is what we are looking for. So 6 is equal to 5 into AD is 5AD, 5AD into 1 is equal to 5AD divided by 2, you cross multiply, 6 2 is a 12 and the 5 cross multiplies to down to the denominator, 6 into 2 divided by 5. 6 into 2 divided by 5, so 6 2 is a 12 divided by 5 is equal to AD. Okay, now 12 divided by 5 gives you 2.4 centimeter. So what is the length of AD? The length of AD is equal to 2.4 centimeter. So this will be the answer for AD, which means the length of the altitude from A to BC, that means this length altitude will come to 2.4 centimeter. Okay, so this is the way we have found the length of the altitude. Please remember, I have already been telling you in the previous classes also, don't get confused that the side on which the triangle is resting, that is only the base. Okay, that is not necessary. To whichever side you draw the perpendicular to, that side will become your base. If you draw the perpendicular on BC, BC will become the base. Here drawn the perpendicular here on AB, so AB becomes the base. Okay, so you have to be very smart in identifying which is the base and which is the altitude. The altitude and the base keeps on changing depending upon the orientation of the figure. Okay, so I hope the working of this question is clear to you. If you have any doubts, you can please raise your doubts when we are having our online classes. So that's all in today's tutorial. If you have any doubts regarding the previous question or this question, please clear your doubts when we are having our online classes. So that's all for now. Please take care of yourself and bye for now.